Hello, my name is Michelle Bennett, and this is my unit plan on quadratic functions and equations, starting with lesson number 1 on through lesson number 5. Each lesson has a verbal lecture with the lecture notes printed. It will also have a required assignment or notes for students to add to their math journal, as well as differentiation for low-level students and advanced level students, in addition to an online or technological resource. Starting with lesson number 1, for my students, I have a printed lecture, and for their math journals, they are going to write the 5-step process of graphing quadratic equations in the form f of x equals a times h minus x squared plus k, where a does not equal 0. Interesting, I'm just noticing that on my board everything is flipped. So, moving on, the first lesson, once the students can write the 5-step process, including plotting the vertex h of k, where f of x equals x squared. Sorry, let me back up. The 5-step process includes, number 1, plotting the vertex where h and k, drawing the axis of symmetry where x equals h, using a chart for organization, find and plot the points on one side of the axis of symmetry, mirroring that image along the axis of symmetry, plotting those corresponding points to there, and sketching your parabolic curve. For my low-level students, once I'm done with my lesson, I'm going to say, okay, students, give me a sign. Does everybody understand that? Give me a thumbs up, yes, if you do. Thumbs side to side, if not so well. And those students that don't understand, they're going to give me a thumbs down sign. And those are the students I'm going to say, okay, let's go back to the corner or up here by my desk, and let's meet to discuss those reflections, stretches, compressions, translations, maximum, minimum, and all those graphing things. This is a huge section, so I would expect quite a few students to need a little bit of help with that. For those students that have maybe seen the graphing of parabolas before, I would ask those students to, in words, discuss the relationship of the parent quadratic function, f of x equals x squared, and how any kind of modifications to that parent quadratic function will change the parabola. Resources for lesson number 1. I do have printed graph paper so that each of my students are using the same type of graph paper. There's no confusion as to labeling your x and your y axis. Aside from the downloadable graph paper, there is also an online graphing calculator, or a great resource in math class is your traditional graphing calculator, which are used a lot in this unit. Also, for an online resource, this particular lesson asks for students to go to a self-check quiz at Glencoe to do a 5-question quiz on transformations. I like that kind of resource and test because it gives the students an answer and grades it right away. That kind of feedback is important when we are learning math. On to lesson number 2. We begin the lesson by discussing the vertex form, similar to this, if you can see it, backwards. Having the students take notes in their math journal provides the written part. Hearing me lecture provides the audio part. Again, interpreting the parts of the vertex form, the vertex, the axis of symmetry, the maximum or minimum values, and the range of each parabola. You ask students to compare this to that, identifying the similarities and the differences, have a class discussion, providing the verbal part of the lesson. For my low students, they would benefit from a step-by-step instruction interpreting the vertex form. How do they find the vertex? How do they find the axis of symmetry? How will they know that those things are correct when they do find those things? My advanced students are going to be able to draw a graph depicting what the translation of the parent graph is 5 units to the left and 4 units down, and drawing a rough sketch of that. The electronic resource for that, of course, the downloadable graph paper, the online graphing calculator for those students who do not have a graphing calculator at their fingertips. Also, mathbits.com offers instructions on how to use different math calculators, graphing calculators. And for this particular lesson number 2, I also have a link to the YouTube video from Khan Academy. I got it from YouTube because our district only allows certain websites to be accessed. YouTube is one of those. The YouTube video, Graphing a Parabola in Vertex Form, is the online version of my lecture. For lesson number 3, I have printed, again, my lecture with the notes of exactly step-by-step example, step-by-step instructions of what I'm teaching, and an example so that they can look at it in the future for future reference. This one is where they're going to identify the A, B, and C values of a parabola. If A is greater than 0, it's a parabola opening up. If A is less than 0, it's a parabola opening down. The axis of symmetry is determined by negative b over 2a. You find the x-coordinate of the vertex by plugging in the x value into the line of symmetry for the original equation, and you find your y-intercept. Those steps for some students are beneficial if they are printed with an example. Other students might benefit from writing those instructions down in their math book, in their own handwriting, in their own math journal. It just depends on the type of student and their learning preference. For lesson 3, low-level students will benefit from the step-by-step instructions on how to graph functions in the form of y equals ax squared plus bx plus c, complete with examples. Advanced students, perhaps I would have those students develop a step-by-step instructional paper for new students explaining that process of graphing functions in the form y equals ax squared plus bx plus c, complete with examples. My resources for my students, including the printed lecture, steps written for certain students, the graphing paper, the graphing calculators online. This one here, I actually am using Hornby, that's the author, Hornby's calculator task from the Alex website, where they are going to do a calculator task. So that is the technological resource for lesson number 3. Lesson number 4 helps students to understand how to convert functions from standard form to vertex form. And again, printed lecture for some students would benefit from writing these steps down in their journal, where they identify A and B, find the x-coordinate of the vertex again, where x equals negative b over 2a, You substitute the x value back into the original equation to determine the y value of the vertex. You use those values, the x and the y, and you substitute it in this equation, and you state the vertex form of the function. Again, low-level students will use graphing calculators either in their hand or online to visually see how, when you change those features, the a, b, and c values of the standard parabola, how when you change that, how it changes, modifies the parabola that's been graphed. Advanced students are going to expand this form of the equation and compare those results to the standard form f of x equals ax squared plus bx plus c. That's just taking what's already been proven, the proof of the vertex form into standard form. It's just asking the students to do that. The resources for lesson number 4 include the student learning guide, the graphing calculators in hand and online. And for this one, I found converting the equation of a parabola, vertex and standard form, a different type of lecture similar to one that I would present, but more verbiage, at mathwarehouse.com, and my students would be able to go there and get better examples to help them understand the material. Lesson number 5, I have created a cooperative learning task that I haven't tested in a classroom, so I'm not too sure of the room for improvement. I know is there, but I'm not too sure of how smooth the task will go. Students are broken into 3 different, or groups of 3, and they are given 3 points, and they need to identify all the important parabola parts of those 3 points. They need to find the function in standard form, convert that to vertex form, give me the vertex, axis of symmetry, minimum or maximum values, domain and range, intercepts, and 3 more points that would be on that same parabola. This task is designed for a student who joined my class on the 5th day of this unit plan. How would my other students want to explain what they've learned to the other student, the new student? What's their best explanation? There's a lot of material when you're talking about a parabola and the parts of a parabola that you want to make sure that that new student understands. So the task would be to create a presentation identifying the parts of a parabola. For lesson number 5, my low-level students will again use graphing calculators to check their work using those 3 points in to find the equation of standard form. Advanced students are going to create 2 or 3 story problems of their own, complete with solutions and multiple choice answers, giving mistakes as possible solutions. A possible common mistake in these is not switching the negative b over 2a value. A lot of people want to put the positive b in there, or if their b value is -6 and they plug it into that vertex form, the negative b over 2a, they forget to make that a negative. I would expect that answer to be one of the possible solutions for their story problems. Resources for lesson number 5 include, of course, not to sound repetitive, the online graphing calculators, the printable graph paper so that all my students are using the same graph paper. Fortunately, Purple Math, a great resource that I like to use a lot in my tutoring sessions. Purple Math function transformations and translations working backwards from the graph provides students with a verbal description of the function. I think for this particular lesson, not only is it important that the students be able to convert from standard form to vertex form, but back again, from vertex form to standard form, and really be able to manipulate those equations into doing it both ways and knowing which equation, which form of the equation is best for finding which parts of the parabola. That concludes my unit lesson plan regarding differentiation. I hope you enjoyed it.